Hello and welcome to this tutorial on one of the most powerful features of Angular, event binding. If you want to create web applications that are dynamic, responsive, and engaging for your users, then mastering event binding is absolutely essential. So what exactly is event binding? In a nutshell, it allows you to listen for and respond to user actions in your applications such as mouse clicks, key presses, scrolling, and much more. With event binding, you can breathe life into your UI and craft rich interactive experiences. Think of event binding like the strings on guitar. Just as guitarist uses strings to create music in response to their finger movements, event bindings lets your application create interactive experiences in response to users' actions. It forms a critical link between your application logic and the user. As the official Angular documentation explains, event binding lets you listen for respond to user actions such as keystrokes, mouse movements, clicks, and touches. In the rest of this video, we will dive deep into different aspects of event binding in Angular, including fundamentals of event binding syntax, how to bind to a variety of events like clicks, key presses, etc., accessing and working with event data, and more advanced tips like event filtering, modifiers, and custom events. By the end of this video, you will be fully equipped to harness the power of event binding in your own Angular projects. So let's get started on this exciting journey into interactive web development. Now let's dive into the core fundamentals of event binding in Angular. The key to event binding lies in its simple yet powerful syntax. To bind to an event, you wrap the event name in parentheses on the left side of an equal signs and provide a quoted template statement on the right side like this. So let's break this down. The event name click is enclosed in parentheses, indicating that we want to bind the click event of the button. On the right side, we specify onSave. This is template statement that will be executed whenever a click event occurs on this button. Angular offers a wide variety of events we can bind to, covering user interactions like clicks, key presses, mouse events, and more. Here are a few common examples. In this, we have a button where we have the click event that is calling a function on click, and here we have an input where we have registered the key up event on that input, and as soon as your key up, then on key function is executed. Then we have a div where we have registered two events, mouse enter and mouse leave. On mouse enter, it will update the component class variable or property to true, and here on mouse leave, it will set the class property hover div to false. In addition to these events, Angular also allows us to define and bind to custom events using EventEmitter. This is useful for communicating between child and parent components. So to demonstrate that, let me quickly create a new component for you. That would be the child component. I will use the generate command c child. Press enter and it would immediately generate a folder with all of the files that are required with this component. Now in the HTML, I will add my link and add the button that will call the notify parent function that we will define now. Now let's go to the TS class, and here I have used the output decorator. So let's import it from the Angular core, and we have to import the event emitter as well. And now I also have defined the notify parent. So now here on click on this button, as soon user clicks on this, we will call the notify parent button. That will then use the notify output and call the emit function on it, and it will pass some value to the parent. Now let's go back to the parent where we are going to consume it. So I'm going to use app component, and as this is a standalone component in Angular 17, so I don't need to declare my child component. I can simply import it in the imports array like this, and I am able to consume it in the app component now. So here I will simply add my app child component here, and now I will listen to the event that I just defined in that component notify, and on this event trigger I will call a function get notification, and I will define that in my TS file as well. So I defined my function, and here I will alert the payload that I'm getting from that event. Now let's test it, but first of all I need to start the application by running the command ngserve-o. that will automatically open the URL in my browser. I got an error here. Actually I did not save the TS file, that's why there was an error, but now it is working. So now let's click on the notify parent, and you can see some value came out from the child and we displayed that with the help of the alert. Now what about accessing the event data itself? This is where the event object comes into play. Event is a special variable that gives us access to the event's payload. So here I will pass the event in this way, and now let's go to the notify parent function. Here I will receive the event, and now for now I will add type any, and now I can alert that. Okay, you can by the way give it any name, E, that would also work. Save it. Okay, if you click on that, we have the mouse event in it, that is basically coming from inside of. So from the child you can pass anything. You can pass a string as well, ABC, like that, and if you click on that you will get the ABC. Okay, so now let's try something else. Instead of button I will add an input type text. Okay, let's pass the event to it as it is, and I will use the same function notify parent. Let's get rid of this button. Okay, so now in the TS file we know that we are passing the event as it is, or on instead of using input you can use the key up as well, so that will notify the parent on every keystroke. Now here on the TS you can give it a type as well, like keyboard event. You have the access to all of the type suggestions of the keyboard event class, like e.target.value. It is saying e.target is possibly null, so here you can add question mark. So for now you can add as any to get rid of this error. Okay, now you can see we have the input here. If you type, that data will go to the parent. Okay, as soon as you type, it will keep sending the data back to the parent. So in this example we bind the key up event and pass the event into notify parent function, that is our event handler, and the event is a type of keyboard event, giving us access to property like target, the element that triggered the event, key or code, the key that was pressed. It will also give us access to the key or code, that is the key that was pressed. We can then access the inputs value via event.target.value. By passing the event to our handler method, we can extract relevant data to perform actions like validation, filtering, and more. So for example, here I will add another event listener input, and here I will add set uppercase, and let's pass it the event, and in the TS I will simply add my input. By default I will give it the empty value, and now here I will define my function set uppercase, and this is receiving the event. For now I give it any type, and here I will set my input is equal to event.target.value to uppercase. Okay, now here I will print my input. Okay, now let's see. Let me remove the alert in the app TS so that I could avoid the disturbance. So instead of that, I will add console log. All right, now let's type. You can see as soon as I type, it will capitalize it. It will convert every character into the uppercase in the real time. So here the input value is accessed from the event and converted to the uppercase. So here the input value is accessed from the event and converted to the uppercase before saving, so the possibilities are endless. Next, we will build on this foundation to bind events in even more powerful ways using template variables. So stay tuned. Now let's continue to our journey into more advanced event binding techniques in Angular. First up, let's talk about the template reference variables. These handy variables allow you to reference elements directly in your templates, making it easier to access their properties and methods when handling events. To create a template reference variable, you simply add hash symbol followed by the variable name to the element. For example, instead of this my input, here in the HTML I will add my input here. Okay, and now I will on every input event I will pass my input to it, and here we will receive that input. Let's go to that function, and here I will expect that parameter my input. So the type I have set the HTML input element. Now you can use my input dot value is equal to this. Now it will update it real time. So now I don't need to display it here because we will be updating the input value directly. So look at that I typed small letter, but it is immediately converting it back to the uppercase. So it will validate and fix the problems of your input in the real time. So in this example, we declared a template variable called myInput on the input element using myInput. In the notify parent function, we passed the template variable as the argument of that function that we are calling. So now within that function, we can directly use that input element and we are updating the value directly in the same function. So no need to go through the event anymore because we can directly access the my input and its value property. So template variables are especially useful for working with form elements and passing data to event handlers. So let's say I have this input email and we need to have the on blur function that would be executed on blur event every time, and we are passing the email dot value. Email is a template reference variable. And now let's go to the TS file and define this function. Okay, I have defined this function and we are getting the email. Now you can define your own separate function, maybe is validate email, and you can implement your email logic here, so it can be more complex as well. And if there is an error, let's define a variable here, email error. By default it is empty. So if there is an error, then it will update the email error property that you can then populate to the HTML. So for example, here I can add h1 tag, h1 email error, and here you can add email error like that. Okay, now let's try it. Right now there is no error yet, but if I type incorrect email, it will give you error, please enter a valid email. Okay, now if as soon as I add @ character and fix it, then if you blur, then the error should be gone. But right now we did not implement the else logic yet, so for that you have to add else, so that will reset the email errors. For example, I added this email, and now if you fix it and blur again, then the error would be gone. Okay, so here on blur handler receives the email inputs value directly via the template variable. Next, let's dive into event modifiers. These modifiers allow you to fine-tune event propagation and default browser behavior. The most common modifiers are prevent default, that basically prevents the browser's default behavior for the event. Then we have stop propagation, that stops the event from bubbling up the DOM tree. Then we have stop immediate propagation, that prevents triggering other handlers on the same element. You can chain these modifiers onto your event bindings. Modifiers are also useful for filtering key events. So for example, here I will add an input and here I will register the key down.enter event, and here let me call a function on enter. Okay, now let's go to the TS file and define that on enter function, and I will alert something random or maybe on enter. Okay, all right, so let me add a placeholder so that I could differentiate. Okay, so here if I use the key down, nothing is happening, but if I press enter, then on enter would be triggered. Also, there is another use case of these modifiers. Here you can add control.z. okay, and here you can on undo, you can call the on undo function. Okay, and now here I will define the on undo function, and then I will use the alert on undo. Okay, now let's try. So on enter, it will only trigger when the enter is pressed, and on undo will fire for control Z. So right now you can see nothing is being alerted. So but if I use control Z, then this alert is visible, otherwise it will not work. So finally, let's explore some advanced techniques. Event delegation is a pattern that attaches a single event listener to a parent element to handle events from its children. This is efficient for handling events on dynamic or large number of elements. So this is a quick example. I have to define some variable. Let me get rid of all of these functions. I think we don't need them right now. Okay, now here I will define on click function, and let me add any for now here. Okay, so now I need to define the items array. Okay, now here you can see that all of the items are visible. So let's look at the code. So we have a UL tag that has the click event here, and then we have the list tag that is using the for loop, and if you click on the UL, then we will call the on click function, and if you click on the list tag, that will still call the on click function, because the click event would be delegated to the nearest parent that is listening to the click event. So by attaching the click listener to the UL, we can handle the clicks on the dynamically generated list elements. So here we can check that if you clicked on the list tag, then we will display the content. So you can do something only if clicked in the list tag. So for example, this is a list tag, and go to the console. Let me clear out everything, and if you click on that, you can see it is being consoled. But in the inspector, I will add some padding, 50 pixels, and here I will add the background color red. Okay, now if you click on anywhere on this red color, the alert would not, the console would not be appeared. So let me show you here. I'm clicking, but console is not showing any log. But if you click on the list items, then it will show the logs. So you can see we have added a click event on the UL, but we are responding only if the target tag was the list. So in this way, you can target a specific element within a parent. So you can also use the host listener to bind events to a component's root element. So for example, here I can add host listener decorator and make sure to import it from the Angular core. And now I will add click event within that, and then here I will define my click function on click that would receive an event, and then we can handle to that event. So here I can show an alert that host element click. Okay, there are two click events, so that's why there is an error. Let me rename it on host click. Okay, now let's give it a quick try. We have added the host listener. Now if you click anywhere on the host, it will work. So for example, in the inspect element, let me show you the host. So this is basically host, and this is the area. So if you click within that area, it will respond. So for example, I clicked and it is saying that host element click. Alright, that was a lot. Take some time to digest these powerful techniques. By mastering them, you will be able to create rich, performant event handling in your Angular apps. As we wrap up our deep dive into Angular event binding, let's cover some common mistakes and pitfalls to watch out for. Mastering these will save you hours of head-scratching debugging. First up, a syntax slip up that's easy to make: forgetting to wrap your event names in parentheses. So remember that correct syntax is this, not this one. So there has to be parentheses around the event name. Leaving out these crucial parentheses will often lead to Angular failing silently, leaving you wondering why your click event handler is not firing. Next, let's talk about the tricky pitfall when working with event to access event data. It's tempting to try accessing properties directly of event like this. So TypeScript may quickly yell at you as event is a type of event which doesn't have a target property. Instead, you need to cast the event to an appropriate type first. So for example, you can do that. You can create, you can just pass the event and go to the TS file. Let's define that function on key event. And now you can console it, but before that you can wrap it in parentheses and here add as HTML input element. Okay, in this way it would be obvious. Even if you are typing, it will give you all of the suggestion that which value to pick. So by casting the event.target to the HTML input element, you are telling TypeScript that this is an input element with a value property. Another pitfall to be cautious of is overusing event binding. While it is great to make your app interactive, plastering click and key up on every element can really slow things down, especially in larger apps. For elements that are added dynamically, such as in an ng for loop, consider using event delegation instead of attaching the event listener to a parent element like we did earlier. So here, instead of adding the click event on the list tag, I added it on the parent. So this way you have to use single click listener on the UL rather than on every list. So finally, a mistake that can lead to sneaky memory leaks: not unsubscribing from the event subscriptions in your components. If you are manually subscribing to events in a component, always be sure to unsubscribe in the onDestroy lifecycle hook. So for example, here on ng init, I have started a timer of that change the interval as per you can change the interval as per your requirement. It runs after every second. So I have imported the interval from the RxJS, and then we are subscribing to it, and we have given it a callback function that there we will have a code to be executed on each interval tick, and we are saving that subscription in a variable, and whenever the component is about to be unmounted on destroy event, we will unsubscribe to that subscription. In this way, we will avoid any kind of memory leaks. So by unsubscribing, you ensure that the event listener gets cleaned up when the component is destroyed, preventing any memory leaks. By keeping these common pitfalls in mind and applying the techniques we have learned throughout this tutorial, you are well on your way to becoming an Angular event binding master. Alright, we have covered a lot of ground in this deep dive into Angular event binding. Let's take a moment to recap the key points we have learned. We started with the fundamental of event binding syntax, learning how to bind the common events like clicks, key presses, and input changes using the event handler. Using this event handler syntax, we saw how to bind the custom events using the event emitter for component communication. Next, we explored accessing event data using the event object, allowing us to grab details like the target element, input value, and more. We leveled up our event binding with the template reference variables, directly accessing DOM elements and their properties. We then dove into more advanced topics like event modifiers for fine-grained control over event propagation and default behavior. We saw how to filter events using key modifiers and how to optimize performance with techniques like event delegation. Through it all, the real power of event binding became clear. It's the key to crafting interactive, dynamic user experience in our Angular applications. By responding to the user actions in real time, we can create UI that feels alive and engaging. So here is my challenge to you. Take the techniques we have learned and start applying them in your own Angular projects. Experiment with different events, get creative with your handlers, and see how you can elevate your app's interactivity to the next level. The best way to solidify your understanding is through hands-on practice. If you want to dive even deeper into event binding, I highly recommend checking out the official Angular documentation on their website. It's a great resource for exploring more advanced topics and edge cases. As you continue your Angular journey, keep pushing the boundaries of what's possible with event binding. Embrace the power it gives you to create applications that delight and engage your users. Thank you so much for joining me on this deep dive. If you enjoyed this tutorial, hit that like button and consider subscribing for more Angular content. Now go forth and build some amazing interactive apps. Happy coding!